And today, welcome everyone also online. Today my presentation is Cucurbits in a smart way. So as my colleague Georg told us before, we offer these smart chips and they are available for several main crops in the industry. So of course we had to develop a smart chip for the Cucurbitaceae family. And these smart chips offer you data automation, but also standardization, especially because we work with several industries, institutes, universities, companies that are located around the world. So standardization in sample preparation is very important. And this smart chip is compatible with our portable P20 and is also compatible with our fine set for the instrument. This is the goal. This is what I want to share with you today in my presentation. I want to share our know-how on cucumber, melon, and watermelon pollen. And especially, I want to share with you how I applied, how I used viability data. And I think that's the most interesting part. So I would like to start with it, to share with you real examples and real cases that happen in the field. I made a small list of ideas that came up to my mind on how we can use viability data, but I will focus on the ones in bold. How our tool, our instrument, our technology can help you to increase production efficiency, how you can control your male flowering induction, how you can control your spontaneous hermaphrodite flowers in your female parentals, how you can use our tool to your nicking trials, producibility trials, and how you can study the influence of climate on your pollination and all your male parentals. So I would like to start first with how you can increase your production efficiency with viability data. I made a small summary on the supply chain of the cucurbits. We start harvesting the male flowers very early morning. I think the earliest I've been was 4:45, very early. And you want to avoid the sun, because sunshine means insects wake up, and you don't want them to visit your male flowers, because that means pollen contamination. So actually, the harvest of male flowers is just a couple of hours. And then you have maybe 1 hour, if you're lucky, for logistics, for transportation, and make any decision. Then your male flowers arrive at the female, like Romeo and Juliet, pretty much. And then you start pollinating. But cucurbits is actually a shorter crop, shorter than tomato. You can pollinate tomato 16 weeks, 15 weeks, 13 weeks. Sometimes you can close a pollination in 3 days. And also the flowers and male flowers, we usually use them for 1 day only. So it's a very short-lived crop, very short-lived pollen. And whatever decision you have to make, you have a very short window. So having a technology like ours can be very beneficial to make the best decision as fast as possible. Let me tell you another example, and for this, I want you all to imagine this scenario. This is something hypothetical. Today is Amphacademy. Today is the 14th of September. And let's say you have one parental male, and you divide them in 3 different sowing windows, because that's what we do. We divide them in several, maybe every week or every 2 weeks or every 10 days. So you have one sowing window, a second sowing window, and a third sowing window. These are the sowing dates and the transplant days. Makes sense with the phenology. So your first sowing window, let's say you have a nectar, was in the field on the 6th of July, the second sowing window on the 16th of July, and the last one on the 26th of July. And then you started pollination end of August for the first window. Last week, you started pollination for your second window. And you expect to start pollination next week, 19th of September. Let's imagine that. But what if you go and visit your females and they're ready actually today? But what if your male looks like this and you don't have flowers? You cannot lose 5 days without pollination. So what you can easily do is recycle. That's a modern term that we should all do, not only with our flowers, we should all recycle. But you can recycle your your male flowers from your old seasons, and you can measure viability from your first season, from your second season, and maybe viability dropped a little bit, then you make the decision, okay, instead of pollinating 2 males for 1 female, okay, I use 4 males, but you still don't lose your pollination window. Another example that I've seen a lot with melon and cucumber is that there is shortage of male flowers. Sometimes it's not enough. Sometimes we are picky and we want to use 3 males, sometimes 2 males per 1 female receptive flower. But it can happen that we have shortage because the ratio was wrong or the season just don't allow us to have enough male flowers to pollinate. So many companies use hormones, PGR, plant growth regulators. And there are several studies on which products we should use and the doses, which lab, timing, sowing windows. There are several experiments in literature about this. And the main result that we want to see is how we obtain more males or male flowers per plant. So our metric will be number of male flowers per plant. And this is just an illustrative example. Then you count how many males you have per plant, and then you choose what's the best product or the best treatment. But it's also very important to check the pollen viability. And of course, you have to make sure that the pollen viability from the pollen from the male flowers, from the treatment that you are choosing, is as good as the control. That's very important. Another example that I prepared for you is the case of hermaphrodite flowers in female parentals. Usually in cucumber and melon, the male parentals, the female are usually gynoecious, meaning that these are parental feminine plants that should only produce female flowers. Should. But every day in the field is a big surprise. So sometimes you find hermaphrodite flowers or bisexual flowers. These flowers have feminine and masculine organs within the same flower. And this can go from very poorly developed until fully hermaphrodite. And this, anyway, is a risk of purity issues. So having an instrument like us can help you to determine, okay, yeah, there is viability, or there was a problem in emasculation, and you find viability, or if you find a high number of pollen grains per flower, then you make the decision, okay, it makes sense to plug out 10 plants in the radius, and not only the plant that you found, because viability was high. Now, as I told you, we are offering our smart chip, and we also offer a standardized universal sample preparation. And for this, that took me many days, and that took me many experiments, but now we have a recipe for you. This is how we recommend the male flowers to look like. In order to have a good sample preparation, you also need a good sample, first things first. And this is how we recommend that the mature male cucumber flowers should look like. This is how we recommend that the male melon flowers should look like. And these are watermelon flowers, juicier. And I would like to share the experiments we did. We tested many things regarding methodology, filters, buffers, especially comparing pellet pestle versus rack. And by pellet pestle, I mean you put your anthers here without any buffer, and you just squeeze them. And by rack, I mean that you put your anthers here, you close the tube, and then you vibrate it with the rack without any buffer. This is what I mean with pellet pestle and with rack. We also tested the amount of number of flowers per sample. We tested 1 flower per sample, 2, 3, 4, 5 until saturation for several lines for these 3 crops. And we also tested equilibration time. And by equilibration time, I mean what's the effect of time when the pollen is in contact with our buffer. So we measure right away. We waited 5 minutes, 10, 15, 20, and 30 minutes using our Amphafluid 11. And I would like to start sharing the results of cucumber. We observed that pollen viability values are higher when we use the rack, just dry vibration. And in terms of pollen grains per flower or number of particles per flower, of course, makes sense that counting is higher when we use the pestle. For melon, we observed exactly the same trend, that pollen viability is higher when we use the rack, and counting is higher when we use the pestle. However, we recommend using the rack because it's the most comparable method to what happens in a manual pollination. And also, when you're using the pestle, you are mistreating the cells. So you're not counting only necessarily the pollen that is good. You're counting good and bad. Regarding the number of flowers, this is an example of cucumber. In red is the bite alpha type here. In blue is the midi type. And in green is the long European type. And this is how the plots or our scatter plots in Amphasys Pro look when we use 4 flowers. So we tested different amounts, different lines for these 3 crops. And for cucumber and melon, we should use 4 to 5 flowers per sample using the rack. And for watermelon, 3 to 4 flowers per sample. So we did all the job. You don't have to do anything. Just 4 to 5 flowers per sample, or 3 to 5 if it's watermelon. For equilibration, for cucumber and watermelon, we found that actually the pollen is highly stable in our buffer. After 20, 30 minutes, still viability is consistent and constant. We recommend 5 to 10 minutes of equilibration. However, for melon, we found a different trend, and viability starts decreasing at 10 minutes. So it's very important that for users that are working with melon, please do not exceed more than 10 minutes. So as my colleague Georg mentioned, if you use the viability template with our new instrument Z40 or P20, our fluidic protocols have been improved. And within the viability template, of course, you will obtain viability results, so you can compare your lines. This is an example of Gallia type, Snow Leopard, Amarillo, and Spanish type. So these are viability values when you use a rack and a good sample preparation. And these are the values in terms of counting. So within the same viability template, you obtain viability in terms of percentage, but also concentration, and concentration per sample. And concentration is in terms of number of particles per milliliter. But if you know the exact volume that you use, and if you know the number of flowers that you use, you can easily calculate the number of particles per flower. And you can also compare your lines in a quantitative way. As a summary, let's remember we should use a rack, 4 to 5 flowers per sample if we have cucumber or melon, 3 to 4 if it's watermelon, or buffer 11, no less than 3 milliliters per sample, 5 to 10 minutes of equilibration, and if you're working with melon, please avoid more than 10 minutes equilibration. And for watermelon, ploidy is also very important. I think we usually use more diploids than tetraploids. However, we offer templates for diploids and tetraploid in a separate way because they're different in terms of amplitude. So let's say you have a Cucurbits smart chip. Within the same chip, you can select if you want to measure cucumber or melon or watermelon, or if your watermelon is 2N, or if your watermelon is 4N, all that within the same chip. And it will be available by the end of this year. And for users that have a P20, this is what they will see. When they insert the chip and they go to the wizards, those are the tutorials, and we are with you step by step. So also training is very easy. And I'm about to finish my presentation, but if you are familiar to any of these topics, or if you would like to start a conversation, we have a Q&A very soon. You can always send me an email, or we can meet during a coffee break also. So I'm very happy to start a conversation. I would like to say a big thank you to the team of Amphasys, the Netherlands, and the team of Amphasys in Spain for their friendliness. And it's very nice working with you. And this is my email if you don't have time, or for the guests online, if you're interested in any question or you're interested in my experiments. And I think now we're ready for the QA. Thank you.